going to go back to 3.1 since we know so much about polynomials, and we're going to go over some characteristics of polynomials. So below are two graphs of polynomials. Aren't they kind of cool looking graphs here? Of course, they're supposed to have arrows there. It's just the program I used it doesn't put it on there. So they would get an error code. So anyways, below are two graphs of polynomials. Note there are no sharp points or holes and that the curve is continuous. Besides awesome, it's continuous. Okay, in a polynomial of odd degree, the ends go in opposite directions as on the left. Does everybody see that? Do you know what an odd degree means? It means, so the highest power of the exponent is either a 1, a 3, a 5, a 7, blah, blah, blah. Does everybody get? That's what I mean by an odd degree. So the way you remember this is the most famous odd degree thing we've graphed so far in our math career is a... Okay, I'll repeat what odd degree is again. The highest power of the x is 1, 3, 5, 7, blah. Yeah, and what would that be? A line, yeah! So does everybody see a line either goes up like this? Do you see? The endpoints are similar to this. The only difference is the middle part is different, right? Or I could have it going this way. Does anybody remember with a line what made it go up to the right versus down to the right? Huh? Yeah. What? Yeah, so the leading coefficient, let's use the math term, the leading coefficient of that x to the power 1, if it was negative, it went down to the right. And if it's positive, it went up to the right. Okay. In a polynomial of even degree, so in even degree, the ends go in the same direction as on the right, like the graph of the most famous even degree, a parabola. And what made a parabola open up like that? When the leading coefficient was positive. And when the parabola opened down, it was negative. Okay, so let's look at this. I want you to guess at what degree this is. Oh, sorry. The bumps on the graph are called turning points. Do you see the turning points? Where it's going up, then down, that's a turning point. Or it's increasing, then decreasing, that's called a turning point. Okay? So the bumps on the graph are called turning points. If the degree is, if a polynomial is of degree n, there will be at most how many turning points? I hear n. Think about a parabola. How many turning points would a parabola have? 1. So guess what it is? N minus 1 turning points. A polynomial of degree n has at most n zeros, though. This is actually really important information. So I don't know if you want to highlight this or what you want to do here, but this is actually key information about the characteristics of a polynomial. Okay, knowing that, can you guess what degree the left graph is and the right graph? I hear a 5. Okay, why did we say 5? There's 4 turning points. There's 1, 2, 3, 4 turning points. So we just went to the next one. We went 5. It could be 7, but it could be 7. How many zeros are there? 1, 2, 3, 4. It is an x to the power 5, but I'm just saying it couldn't be an x to the power 3. But it could be 5 or more based on the knowledge of the turning points, right? So, but it says at most n minus 1 turning points. So it couldn't be 7 then, if that's the case. Okay, how about this one? So we have 1, 2, 3. So we're saying 4. How many zeros do we have? 1, 2, 3, 4 this time. Okay. So here are two quartic polynomial functions. Again, let's put the arrows on here so we don't get error codes. Look at the equations of the graphs below. What effect does the leading coefficient have on the graph? What does the effect of the leading coefficient have on the graph? Yeah, it determines what direction. Do you see this is positive, it's opening up. This is negative, it's opening down. Does everybody see that? How many zeros could a quartic have? Quartic is 4, people. So how many zeros could it have? It could have the same amount, 4. How many turning points could it have? 3. Hey, we're listening. Very good. Here are two cubic functions. Degree 3. Look at the graph below. What effect does the leading coefficient have on the graph? This is positive. What's the difference between the positive and the negative leading coefficient? Yeah, well, it's not a matter of opening up or down because they're going in opposite directions. So let's try again. Yeah, this one's going up to the right when it's positive. This one's going down to the right when it's negative. Key characteristics, okay? Look at the factored form. What do you think that advantage would give us? The zeros. Does everybody see? X plus 1 produced. That 0 there. X plus 3 produced. That 0 there. X minus 1 produced. That 0 there. Look at this one. X plus 1 produced. That 0 there. X plus 3 produced. That 0 there. Actually, this is the same graph except the negative is different, right? So there we go. Let's put the arrows on this graph just so we don't lose error marks. So does everybody see the factored form, why we need to factor? The only thing missing we have is, where does it cross the y-axis? It crosses it right here. Can you see anything noticeable about the equation? It's the constant, yes, the last number. Does everybody see? The last number is the y-intercept. Why is that the case? No. Yeah, you guys, when you're trying to find your y-intercepts, all the x's go to 0. That's the only one that doesn't have an x. So you see, that's the only one that's left. Yeah? Now, the thing about if it's in factored form, you would actually have to calculate it, right? Because you would get 0 plus 1, 0 plus 3, 0 minus 1. You'd have to multiply, and you'd still get it that way. So what is the advantage of factored form? Easy to solve x-intercepts. And the y-intercept, it's actually easier to have it in non-factored form, right? The y-intercept is the constant term. Does everybody see? Okay, so I want you to grab your graphing calculators, and I want you to graph each of these graphs, and I want you to find, actually, we don't need to graph these, do we? We can just tell. What am I talking about? Put your graphing calculator away. Okay, here's a polynomial function. What's the degree? 3. Does everybody agree it's 3? What type is this? If it's the highest power is 3, what is it called? It's a cubic function. Very good. What's the leading coefficient? 6 is positive 6, which means what? It's going to? No, odd looks like a line, so it's going to go like this, right? Yes? It's going to start down here and end up there, yes? Oh, just wait. What's my constant term? Negative 8. What's the maximum number of x-intercepts I could have with a cubic function? 3. Okay. What degree is this? 5. That's a quintic function. What's the leading coefficient? Negative 2. Now, this one's negative, so what does that mean? It's going to start up there, and it's going to end down there, right? Like a negative line going down. Oh, yeah, you can see the dance moves coming. Okay, how about constant term? It's 1. And what's the maximum number of zeros? 5. Okay, next one. What is the degree? Ooh, I didn't trick you on that one. Very good. It is 4. Sometimes it's not in the right order. So what's that called? It's a quartic. A quartic. I doubt they'll ever ask that, but it's not like it's hard or anything. What's the leading coefficient? Negative 10. So what does that mean? How are they going to open? Down. They're going to start down there, go whatever, and come back down. Does everybody see that? Yeah? What's the constant term? 0. How many x-intercepts could this have? Maximum 4. What's this one? 1. It's a linear, yes. So linear is a polynomial if you haven't figured that out, yes. Leading coefficient? 11. So which way does it go if it's positive? Yes, that way, right? Okay, my constant? 3. And we knew that was the y-intercept, because remember y equals mx plus b? Yes. And what's the maximum number? 1. Makes sense? Ooh, what do we got here? We have a 2. What is that called? Quadratic. Yes? Leading coefficient? Negative 0.4, which means it starts down there, comes up, and comes back down. Yes? Okay. What's my constant? 4, which happens to be my y-intercept, right? And what's the maximum number of zeros? 2. How about this one? 4. What's that called again? A quartic. Yeah. What's the leading coefficient? 5, which means what? Starts up here and ends? No, same way. It's like a parabola, remember? Parabola. Okay, what's my constant? 4. Yes, it's like a touchdown. Very good. Okay. And how many zeros could I have? 4. Uh-oh. What's the degree there? 0. What's this called? A constant function. Very good. What is the leading coefficient? Huh? They're both negative 7. That's the constant function, right? Okay, and none. None. Okay.